Hi guys, welcome to Anatomy Lesson 7.05. We're going to do an overview of the sliding filament theory. And we're going to kind of look at how all of this works together. So hopefully by now you have your vocab down. So for example, on this video, we're using the term sarcomere. We have an A band, we've got our I bands, we've got our H zone, we've got our Z lines. And so those are all terms that we're going to be using to explain what happens when muscles contract. And let's make that our starting point. What is the sliding filament theory? The sliding filament theory describes sliding filament theory. It's really not a theory, it's kind of been proven, is the process via muscles contract. And it's called sliding filament because one set of filaments slide past the other set. And just to refresh our memories, let's go through one more time. So we have a Z line, got actin that comes off the Z lines, a little further than that. Got a Z line over here, actin that comes off here. So I've got a Z line, Z line. This is my actin. And we said the actin is made of two strands of actin and a strand of tropomyosin all twisted up together. And then in red, in between, we have these thicker myosin molecules. So these are myosin in red. And they're anchored in the middle. They're a little bit thicker in the middle. And this creates the banding. And so let's just go back over our banding. Grab a different color. So if we look at this region, this is the A band, where it has overlap between the actin and the myosin. In the middle, where it's just myosin, I have my H zone and my M line in the middle. Do the M line in a different color. And that's too close. Purple looks too much like do orange. So I've got this M line. And then over here, and this would extend so the actin goes go this way, goes to both sides. Where it is just actin, that is an I band. I band. And okay, so, and we said that's in a relaxed sarcomere. So up here at the top, I have a relaxed sarcomere. I have a sarcomere partially contracted. And here I have a sarcomere completely contracted. Now they actually did their Z lines in black and their actin in blue. So you have to kind of look at the relationship between the myosin and the actin. And I want you to pause the video and I want you to see if you can figure out what has changed from the relaxed sarcomere to the contracted to the completely contracted. All right, welcome back. Hopefully you made a few observations. Now, the only thing I don't like about these is I think I copied and pasted these, and so I lost some of my perspective. So from this to this to this, my myosin should all be the same length and should stay in the same position. Down here, the myosin looks a little bit bigger. That's because I think my I zoomed in on this a bit and my perspective changed. But ideally, I would have kept these at the same perspective. Okay, so if the I bands are actin only, so here we see my I band, we have actin only. And here I have my H zone, which is myosin only. Tell me what's happening to the H zone and the I bands as we begin to contract. Well, here, my H zone is about a pen length, and it hasn't changed too much here. But do I have any area down here in the completely contracted sarcomere where I have just myosin or just actin? Let me draw these in a little bit darker so you can see them. Since they were kind of faint. So up here in the areas where I have just actin and the areas I just have myosin, down here when I get to the completely contracted sarcomere, those are gone. Look how thick the I bands are. They're super thin. Look at the H zone. It's completely gone and I have full overlap. Well, I'm going to pause the video and I want to do a quick demonstration for you. I have to set it up first. Okay, welcome back. In order to get this fit, I kind of have to go catty corner here. Sorry about the delay in pausing. I've got horrible lag. I'm recording actually at the school today. So on my gloves, you can see the black actin lines. This glove is a little neater than this glove, and the red represents the myosin. And you see in the middle where I have just the myosin, that's going to be my H zone. And I don't really have an M line, but you can see that there's definitely going to be down here, I have just actin, and then I have actin myosin overlap, and then I have just myosin. What happens is these myosin fibers are fixed. They stay in place. What they do is they reach up with those cross bridge heads and they grab the actin and they pull the actin towards the center of the H zone. And as I do that, you can watch the H zone shrink and look at the actin myosin overlap. It becomes almost 100%. And that's how the entire sarcomere shortens. And now imagine that happening over hundreds of thousands of sarcomeres. And then when we go into the relaxation phase, everything returns back to its starting position. And we have the H zone that reforms, and I have my I bands out here where my thumb is pointing. So again, to shorten, the myosin cross bridge heads reach up, they attach to the actin, it pulls the actin fibers towards the center of the sarcomere, and we will keep going. I can't quite get my pinkies in there. And then when we relax, we pull back out. So that process from, I'm going to go ahead and pull my hands out here, from the nerve impulse firing to the actual shortening is what we're going to talk about in like the next 3 videos. But let's break down some takeaways here. I'm going to grab purple. So we said the sliding filament theory is the process where the muscles contract. And just some general points here. The actin and myosin, so the myosin cross bridge heads pull the actin fibers to the center of the sarcomere. In effect, shortening the sarcomere. And when a muscle contracts, that's basically what we're looking at. It goes from being a certain length and it shortens up. The entire muscle shortens. Down here we have a little diagram. I'll just talk about that too. So one of the things they compare these myosin, and what I have down here in pink are the myosin cross bridge heads. Let's color those in. The way they work is in very much effect like an oar. So when you row, you dip your oar in and then you pull the oar back and then you lift the oar out and you have to rotate it back around and then you repeat. That's what the myosin cross bridge head does. It instead of dipping into the water, it attaches to the actin It rotates to the center, pulling the actin to the center. It releases, and then it comes back around and it resets. You can think of that myosin cross bridgehead. Instead of an ore in water, it acts against the actin in the same way where it attaches, it pulls, releases, and comes around. Okay, that is kind of a quick introduction to how this whole process is going to work. So since I'm a little bit shorter on this video, I think my next video is going to be long. Do I want to introduce the next topic or not? Decisions. I think we'll just call this one a day, and we'll start with the neuromuscular, the triggering of the shortening of the sarcomere and what happens with the nerves in the next video. All right, all for now. And since I've got lag, it's going to take me forever to stop this. So you could stop the video now. It's probably going to carry on quietly for about 30 seconds.